In property 6, notice that the base of the logarithm is not the same as the base in the argument. But here, this property is important because it allows us to take this power and write it as a factor. We can write this as r multiplying log base a of m. This is especially useful when we have very large numbers. For example, I wouldn't want to have to multiply 125 by itself 9 times and then determine 5 to what power gives me that number. So instead, we can take that 9 and write it as a factor of log base 5 of 125. 5 to what power equals 125? Well, I hope you know that 5 cubed is 125. So my log is equal to 3. This is 9 times 3, or 27. We can always write that power as a factor. Sometimes we're going to use it in reverse and write the factor as a power. Question 7 is an exponential expression, but notice that the base of the exponent is the same as the base of the log in its power. When the bases are the same, we say that this equals m. I think this one is best illustrated using a logarithm we can evaluate. Log base 3 of 9. Do you know what that equals? Think about the question. 3 to what power equals 9? 3 to the power of 2 equals 9. So we know that log base 3 of 9 equals 2. That means this question is 3 squared. But we already knew that it would equal 9 because our property says when the base is the same as the base here, the answer is m. Finally, we have property 8. This property we're going to use frequently when we're solving equations. When you have two logs that are equal to each other, now notice there's no adding and subtracting of other terms. There are no constants. There are no factors in front of the logs. We simply have log base a of m equal to log base a of n. Then we can just ignore those logs and say that m equals n. We'll look at examples with that more closely when we are looking at solving exponential equations.